I should get the next question. Okay. So let's clean all of this up from the last question and move on to the next one. So the constraints of a problem are listed below. What are the vertices of the feasible region? So we're going to draw our coordinate plane first of all, and we're going to go through this problem step by step. So the way I like to think of it first is considering the hard boundaries. So the hard boundaries here would be that x is less than or equal to 0 and y is greater than or equal to 0. So this is going to constrain our answer to one of the quadrants. So if our x value has to always be less than or equal to 0, so our x axis is here, our y axis is here. So if x must always be less than or equal to 0, we are going to be constrained for now to work in this plane right here. So the left half side of the coordinate plane. If y has to be greater than or equal to 0, so meaning it has to be above the x-axis, then we are now constrained to just this quadrant. Okay? So that's important to know. So that takes care of two of our constraints. We know that we're going to be working in this quadrant right here, which is quadrant 2. So it's going to be circle quadrant 2 right here. Okay? And now we can actually start working with the lines that go into this into this quadrant. So I like to rewrite the actual constraints in terms of equations of lines or inequalities of lines. So I'm going to change them first into a format where y is isolated. So I'm going to subtract x on both sides, and I'm going to get 3y is less than or equal to 6 minus x. Then I'm going to divide by 3 on both sides, and I'm going to get y is less than or equal to 2 minus 1/3 x. So this tells me two things, this constraint right here. First, it tells me about what the y-intercept is. So the y-intercept is, so just a reminder, the y-intercept is the value without the variable x in front of it when we're talking about inequalities or equations of lines. So this is the intercept, and this is the slope, telling us what direction the line is going in. If it's a positive slope, line's going up, negative slope, line's going down, and how steep it is. So we know that the intercept of this line is going to be 2, and we know that it's going to have a negative slope. So the line itself, so let's wait off to draw it. Let's get the other constraint first actually, just so we get the vertices. So we're going to convert this and isolate y. So I'm going to subtract by 4x, get 6y is greater than minus 4x plus 9. And then I'm going to divide by 6 on both sides. So y is greater than or equal to minus 2/3. It's 4/6. X plus 9/6 is 3/2. So this tells us one more thing, that our other intercept here is going to be at 3/2. So let's assume this is 2 and this is 3/2. So the other thing that it's telling us is that at some, okay, just probably this person has drawn it better than I can. So these lines will intersect, so they both have negative slopes, correct? So as you can see from the images here, because they have negative slopes, the one with the y-intercept of 2 actually has a less steeper slope, so it's going to look something like this. And this slope is 2 times steeper right here, because we have a minus 2/3 slope versus a minus 1/3. So the second line, the one with the intercept at 3/2, will have a steeper slope. So it's going to look something like this. And now they both have negative slopes, but they will intersect at some point here. And we have to find the value of this point. So finding the value of this point is as simple as setting both equations equal to each other, the ones that we found here, because we want to find what common point they share. So what common x value do they share? Because obviously, if two lines intersect, they have to have a point of intersection, meaning they share the same x value and the same y value of that point of intersection. So if we can find that point, then essentially we found our region. So our region, remember we're working in the second quadrant, and our region will be bounded by these 3 points right here that we've drawn. So let's set them equal to each other. So we're going to have 2 minus 1/3 x equals minus 2/3 x plus 3/2, and I'm going to add 1/3 x to this side, and I'm going to get minus 1/3 x plus 3/2. I am going to subtract 3/2 to this side. I'm going to get 1/2 is equal to minus 1/3 x. And to isolate x, I am going to multiply by minus 3 on both sides, and I'm going to get that x is minus 3/2. So we have the x value of intersection. Now we just have to find the corresponding y value. By doing that, you could just plug it into either one of the equations, since both equations share the same point of intersection. So I'm going to choose to do it on the first equation. It looks a lot simpler to solve, potentially. So actually, let's go with the second one. So y is equal to minus 2/3. I'm going to plug in minus 3/2 here, and I'm going to add 3/2. And as we can see here, get my pencil back, right here this term just goes to 1, and we're going to add that to 3/2. So that's the same thing as 2/2 plus 3/2. And finally we get that y is 5/2. So we found our point of intersection. Our point of intersection is minus 3/2 and 5/2. And the points that make up our boundary would be the two intercepts here that we found and this point of intersection. So our two intercepts both have an x value of 0, and their y value is the value of the intercept. So we're going to write that the first intercept 0, 2, and the second intercept 0, 3/2. These 3 points make up our boundary. So that's the solution. More specifically, answer choice C, I believe. Yes, answer choice C. So let's just look through the work here. Obviously, the work that went into these images, very well done, and actually showing what the feasible region is inside of here, and showing the vertices that we found as well. So the math that was actually used to find it isn't shown here, but you know, hopefully you could see from this video how it's done, and it could be found this way. So great use in the solution. Okay, the solution is correct.